As students, it is very happy that I am seeing today to all of you in this wonderful holiday, Sunday. But anyhow, I don't want to disturb you, but during the holidays, it is better that you can play this video again and again and understand the subject very much. In the previous classes, I've been explaining about what is a, take for example, what is a test of hypothesis, and some examples for that. Now it is a continuation comes here. It comes in second unit. In the second unit, we know that experimental design. We are designing several experiments, and that designing we are testing whether we have to accept or reject. That's what our aim here. So, in the past classes, I was taking one-way analysis, that is completely randomized domain, where only one way of analysis. It may be of column wise or row wise. That's what we have discussed. Now let us take these are one way analysis. Okay, now we are going to talk about two-way analysis. Two-way analysis, what is the meaning of that? We are analyzing the data on both sides. Both sides, I mean column wise as well as row wise. We have to analyze whether there is a significant difference between column wise as well as in the row wise. That's what we are going to discuss now, and this comes under the topic randomized domain, randomized block domain, or BD we say. So usually this consists of two-way analysis. That's what we do. Okay, so we know that what is two-way analysis, and that I was explaining that in another video. Now that's what I'm not going to discuss in this video. In this video I am going to discuss about how to solve it. That's what. Now let us take one problem here. This worksheet, 6 worksheet. There are so many worksheets in which I have taken so many problems, and each worksheet solves the given problem by one way or two way or three ways. Now a set of data involving 4 tropical feedstuffs, A, B, C, D, or 4 tropical feedstuffs, are tried on chicks, and the data is given here. Okay, so what we have to do to analyze the data. So what's the meaning of the analysis of the data? It's nothing but whether there exists a significant difference between the column wise and as well as the row wise. So column wise there are 3 stuffs, A, B, C, D, and row wise there are 4 stuffs, and column wise 1, 2, 3, 4, 5. 5 what can I say, that 5 treatments may be there. Through here our aim is that to see whether there is a homogeneity column wise as well as the row wise. That's what our aim here. Okay, so this is what you have to do by two-way analysis. That's what you have to do. Okay, so this problem is connected with actually two-way analysis. Now let us take this problem. A, B, C, D are stuff. We can take this as treatments T1, T2, T3, T4, T5. Our aim is that whether there is a significant difference between the columns or between the rows. That's what our aim. We already know that the first step any two-way analysis is about making null hypothesis. Okay, so this is what null hypothesis. We know already null hypothesis. We know that it is a blind idea. The result is unknown, we have to do statistical tests, and that will give the result of this hypothesis. Null hypothesis meaning is that we assume that there is no significant difference, or we can say that there exists a homogeneity among the columns, and that's what we assume. Okay, so this assumption we call it as null hypothesis. It is denoted by H naught denoted by. So there is no significant difference between feedstuff as well as treatments. So there are 5 treatments are here, and the A, B, C, D feeds are there, feed stuffs we can say. So we assume that there is no significant difference between feedstuffs as well as treatments. So it is a two-way analysis. Therefore we must take both variables, I mean the column variables here, the treatments, and row variable here, feedstuffs. Now next step here is about the alternative hypothesis. That is the next step. Okay, so alternative hypothesis means opposite of the null hypothesis. Here we assume there is no significant difference between feedstuff as well as treatment. So opposite of this, yes, there is a significant difference between the two variables, feedstuff as well as treatment. So opposite of null hypothesis, we say the alternative hypothesis. Okay, right, so this is what the second step. Then automatically the third step comes. Now this is mathematical analysis. First two are hypothesis, and third one, step third, is calculation of F statistics and calculation of F statistics table wise. So table value of F we have to find out, and calculated value of F we have to find out, and then we have to compare them. Now look at that. The given the data or matrix you see here, all these are these up to this only, all are 2 digits numbers or 3 digits numbers. So definitely in our way to obtain the two-way ANOVA, we have to square them, we have to add them, you know already well about that. Okay, so it is better that we have to reduce the numbers inside this matrix. So how to reduce without loss of generality of mathematics? If you take any entries close to all these and subtract it from the entries here, then the sense of the matrix will not change. That's what mathematic people say. What they say, if you subtract any number from this particular matrix, okay, and if you subtract them, you will get a new matrix, and that sense of the matrix will not affect our sense of the matrix. That's what the mathematics people say. So what we do here, very close to all these numbers, I can take as some 50. Okay, 50. Or any way you can take for example, you take least number and upper number in this particular matrix, then add them, divide by 2, the average of least number and the big number, which number comes, that you can take as a central number. That way also you can take. And that way I am taking 50 number and subtracting all these entries from 50. What I will get? 55 minus 55 I will get, and that's what I am writing here. The second one is 49 minus 50 minus 1 I will get in the second row and second column, and you will get here second row second column minus 1. Then 42 comes, 42 minus 50, minus 8 comes, and minus 8 comes here also, first third column, and first second row, third column, minus 8 I'm getting. Similarly I can get all these entries. So subtract 50 from all these entries, don't take this total, all these entries you have to subtract 50 from all these entries, and you will get this matrix. So this matrix only will get, okay, this matrix, don't take total. Now this is the matrix, the reduced matrix. Now our aim is take the variable of the treatment as x1, x2, x3, x4, x5, and these feed stuffs as y1, y2, y3, y4. Okay, so that way I have taken here y1, y2, y3, ya as a, b, c, d, and treatment, first treatment as x1, second treatment x2, third treatment x3, fourth treatment x4, and fifth treatments as x5. Right, now the total we are finding out, and then we are squaring the x1 square column, and then we are writing here. Okay, so x1 column you are squaring, and then you are writing here x2 square it, this column, and write here x3 column is this, square it, and write here x4 column is here up to this, square it, and write here x3. Similarly x4 and x5, x4 square, x5 square. Okay, now our aim is that we are adding this number and writing the total here, adding this number and writing the total here. Similarly adding this row and write the total here, add the third row, write the total here, add fourth row and write the total here. Now similarly what you do is that add this column or write the total here, add this column and write the total here, add this column, write the total here, add this column, write the total here, add this column, write the total here. If you add this and this, you have to get 695. The same value you have to get by adding these also, you will get 695. And this also we have to add, you have to add this, write this, and then do for this columns also. Why we do all these things? Because formula needs all these values, that's why we do all these things. Okay, now what is n? Okay, n means the total observations. Now look at the problem given to us. How many observations are here? 1 2 3 4 5, 1 2 3 4, so 4 into 5, 20. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So 20 observations we make here, and therefore n equals 20. Now what is this t? That is step number 2. T is nothing but this total, 695. I already told you that if you add this direction, you have to get 695, and that's what t, the total value, 695. Now the correction term we have to calculate here, that would be step number 3. Correction term is t square by n. T, we already know that 695. That square divided by n is 20. So if you simplify this, what you get is 24,151.25. 24,151.25. That's what we have here. The correction term is this. Why this correction term is needed? Because we have to subtract this from this sum. Okay, very nice. Now let me calculate this TSS. So before calculation, what is the expansion of this? That's what you have to understand. Total sum of squares, total sum of square, that's the expansion of this. So what's the meaning of here? Now look at the table here. This is x1 square, am I correct? If you add all of them, you are getting this. This is called the sum, sigma x1 square, am I correct? So if you add all of them, you will get this. Similarly, sigma x2 square, if you add all of them, you will get this. This is what sigma x square. This is what sigma x3 square. This is what sigma x4 square. This is what sigma x5 whole square. So substitute all the values here. Summation of x1 square plus summation of x2 square plus summation of x3 square plus summation of x4 square plus summation of x5 square minus t square by n. We have to subtract the error terms from this summation. So we already know that sum of x1 square is 14371. Sum of x2 square is 13623, and sum of x cube squared is 15586. Sum of x4 square is 5612. Sum of x4 square is 15586, and sum of x4 is 5612, and sum of x4 is 5612 plus the last sum 12753. The last sum 12573 minus t squared minus n, that already we have calculated here. Then you substituting here. Okay, so you are adding all those things. Then we are substituting this, and this is the value of TSS. 30,793.75. So you have to use calculators. A lot of shortcuts are there to find the sum of all these things that you should know. Then only you will get the answer as quick as possible. Okay. Now TSS, total sum of square value, is 37,793.75. The next thing that we have to find out is SSC, that is sum of square column wise. Sum of square column wise. Sum of square column wise. So this is nothing but summation of x1 square divided by n1, number of observations, plus sum of x2 square n1 plus sum of x3 square by n1 plus sum of x4 square divided by n1 plus sum of x5 square divided by n1 minus t square by n. Okay, now what is this summation of x1 square? Look at the table again. If I minimize, you can see that. Now look at that. This is what x1. If you find the sum, you will get this 127. Okay, so here you have to substitute that 127 square divided by, what is this? 4. 4 means the number of filaments in that particular column. 1, 2, 3, 4. So that 4 you have to write. Now what is summation of x2 square? The summation, this is x2, summation is this, therefore 195 with summation of x2. So summation of x2 squared is equal to 195 squared divided by 4. Okay, now let me come again. There's some disturbance coming there. Now look at that. This is what summation. Now summation of x3 whole square divided by n1. Summation of x3 is here. Is add, you will get summation 122. So 122 square divided by 1, 2, 3, 4. So 122 towards that. 122 square divided by 4 plus the fourth term summation is equal to 90. So 90 square divided by 1, 2, 3, 4. Sorry, here 1, 2, 3, 4. Similarly, the last one is 161 square divided by 4 minus t squared by n. So t squared by n is 24154.25. That's what here. If you find the answer for this particular long expression, you will get 1613.50. 1613.50. That's what you get. Therefore, sum of square column wise is equal to 1613.50. Now, what is SSR? SSR means sum of square row wise. Column wise we have found out just now. This is column wise we have found out for these 5 columns. But now we have to find out row wise. Sum of squares row wise we have to find out. So row wise means what? This one. First row, second row, third row and fourth row. Only 4 rows are here. Am I correct? Now look at that. That is nothing but this summation of y1 square is minus 31 whole square. Minus of y2 is 105. Minus of y3 157. Summation of y4 equals 464. So summation of y1 minus 31, summation of y2 105, summation of y3 157, summation of y4 664. And then how many elements are there in that row? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So in this particular formula, SSR equals summation y1 square divided by n2 plus summation of y2 square divided by n2 plus summation of y3 square divided by n2 plus summation of y4 square divided by n2 minus t square by n. Okay. So n1 means number of elements in that particular row. Now what is summation of y1 square? Summation of y1 square is minus 31. So minus 31 squared divided by how many elements are there in the row? 1, 2, 3, 4, 5. So that 5 we have to write here plus the second sum, summation of y2 square equals 105. 105. So 105 square divided by how many elements are there? 1, 2, 3, 4, 5. Similarly, third row, summation of y3 is how much? 157. So 157 square divided by how many elements are there? 1, 2, 3, 4, 5. That 5 you are dividing plus the last summation of y4 equals 464. So 464 square divided by 5 minus t squared by n. T squared by n is 24151.25. So 24151.25. You simplify them, you will get this 26,234.95. Okay, so that's what we get there. So this if you cannot understand quickly as I teach this, you play it again and again so that you can understand very easily. So you play it again and again, this particular video, 1 time, 2 times, 3 times, 4 times, 5 times, as the case may be. Some students may be getting the answer within 1 time. Sometimes you have to play 2 times to understand. Sometimes you have to play 3 times to understand. Sometimes 4, 5, 6, 7. So according to your slow that you are learning, it will take many times that you have to play this video. Come to the point here. So we have calculated TSS, SSC, SSR, okay, The one more thing is SSE also we have to calculate, because all these are needed to substitute in this particular table, ANOVA table for two-way. Okay, so for this only we need all these calculations. Without calculating TSS, SSC, SSR, SSE, we cannot substitute here. So step number 7 is that we are trying to find out SSE. Okay, now what is SSE? Now look at that. SSE means sum of square error. Sum of square error. That equals what is this TSS? That TSS minus SSC minus SSR. Total sum square minus sum of square column wise and minus sum of square row wise. So if you subtract the sum of square column wise and sum of square row wise from total sum of squares, that is called sum of square error term. Sum of square error term. That's what you have to understand. Okay, right. Now let us so that you substitute that value here. TSS how much? 37,793.75. Now TSS 37,793.75. What is SSC? Is 1,613.50. 1,613.50. And what is SSR? SSR is 26,234.95. 26,234.95. Okay, right. If you simplify that by using the calculator, by using a shortcut methods, you will get 9,945.3. 9,945.3. That's what SSC. Okay, so that is what we have here as SSC. So after getting the TSS, SSC, SSR and SSE, we are coming to the table here. This is called ANOVA table for two-way analysis. Two-way analysis. You must remember that the two-way analysis comes in RBD, randomized block domain. There only we are using two-way analysis. One-way analysis done on CRD, completely randomized domain. Therefore here the two-way analysis we have to make. Suppose it is a Latin square method. The Latin square design, we have to use the three-way analysis. Now let us do the two-way analysis here. Okay, two-way, could you remember what I said? Two-way, column wise as well as the row wise, whether there is a homogeneity with respect to column wise and as well as row wise. Is there any homogeneity? The other way is that no significant difference exists between column wise or row wise. The homogeneity, no significant difference, both have the same meaning. Now let us analyze the ANOVA for two-way or two-way analysis of variance. We know that this is the whole table of two-way analysis. And the first one is source of variation, sum of squares, degrees of freedom, mean square, variance ratio. Variance ratio means the calculated value of f and then table value of f. So all these things we have to calculate now. Now let us take the source of variation as column wise, column, between the column, whether there is a significance difference or not, between the rows, whether there is a significance difference or not, and between column and rows, whether there is an error or not. So all these things, that's what we are going to discuss now. How to find out the sum of squares? SSC already we have calculated. Now go back and see. Yes, SC equals 1,600 1613.50. That is what SSC. Here C means number of columns here. Go back and see the problem. How many columns are here? Treatment 1, treatment 2, treatment 3, treatment 4 and treatment 5. So there are 5 columns are there. So that is what this C. So C means number of columns. So number of columns is 5. 5 minus 1 equals 4. Now mean square column wise calculation is very easy. How it is very easy? You are dividing this SSC by the degrees of freedom. Okay, C minus 1. Divide this SSC by C minus 1. That is the formula for mean square column wise. Mean square column wise. This is the formula. So SSC we have already 1613.50 and C minus 1 is 4. So substitute that 1613.5 divided by 4. We get 403.38. 403.38. So the MSC mean square column wise is 403.38. So in the same way we have to calculate between rows also. Okay, so SSR, sum of square row wise, already we have calculated here. Sum of square row wise, sum of square row wise we have calculated here as go back, see there, 26,234.95. So SSR 26,234.95. Now again, what is the degrees of freedom for between the rows is R minus 1. What is R? What is R? The number of rows. Number of rows. We know that from the given problem, the rows are the foodstuffs. How many foodstuffs? A, B, C, D. So 4 foodstuffs. So how many rows are here? 1, 2, 3, 4 rows. So that is what is given here. So R minus 1. 4 rows minus 1 equals 3. So we have got SSR value, we have got R minus 1. If you divide this by this, what we get is mean square row wise. Okay, if you divide this by this, what we get is mean square row wise. So SSR divided by R minus 1. So SSR is 26,234.95 divided by R minus 1 is 3. So if you divide this by 3, what you will get is that 8,744.98. 8,744.98. So this is what MSR, mean square row wise, mean square row wise. Okay, right. Now one more thing we have to calculate, that is SSE. What is SSE? You go back and see there. SSE we have already calculated as 9,945.3. 9,945.3. That is what? Sum of square error. So that is what we are substituting here. Now what is the degrees of freedom? So degrees of freedom for SSE is C minus 1 into R minus 1. C minus 1. What is C here? Number of columns. Am I correct? That's what we discussed already. Number of columns. And R denotes number of rows. So how many columns here in this given problem? Number of columns is 1, 2, 3, 4, 5. Number of rows is 1, 2, 3, 4. So that's what we are substituting in this table. So in this table we are substituting C minus 1 into R minus 1. So here 5 minus 1 4, here 4 minus 1 3, 4 into 3 12. As we did before, if you divide this by this, if you divide SSE by C minus 1 into R minus 1, what we call is mean square error. So mean square error equals SSE divide by c minus 1 into r minus 1. C minus 1 into r minus 1. Okay, that is what MSE. So SSE divided by c minus 1 into r minus 1, SSE divided by c minus 1 to r minus 1, SSE 9945.3, 9945.3 divided by c minus 1 into r minus 1 is 12. If you divide them, you will get 828.78, 828.78. So now we have calculated the mean square column wise, mean square row wise, and mean square error. Mean square column wise, mean square row wise, and mean square error. So now how to find out the calculated value of f? Okay, we have to find the calculated value as well as we have to find the table value. Calculated value as well as the table value, both we have to find out. Now calculated value for column wise can be obtained by we are comparing the mean square column wise value and the mean square error value. We have to compare this value and this value, and the greatest value you have to write in the numerator. Greatest value you have to write in the numerator, and smallest value among these two we have to write in the denominator. Okay, maximum in the numerator, minimum in the denominator among these two. Sometimes MSE may be greater than MSE. Sometimes MSE may be greater than MSE. So we cannot say that always MSE is greater than MSE, or we cannot say that always MSE will be greater than MSE. Okay, so sometimes different. This may be greater, this may be lesser. Sometimes this may be lesser, this may be greater. But to get the calculated value of f, the greatest among these two we have to write in the numerator, and the lowest between these two you have to write in the denominator, and that will give you the calculated value column wise. Calculated value column wise. Now come back here to our discussion here. Okay, MSE value in this particular case, the value is 403 or 403.38, 403.38. that is MSE. Now what is MSE? MSE is 828.78, 828.78. Okay, now let us compare these two, MSE and MSE. The greater value is this, MSE, mean square error. That value is 828.78, which is greater than 403.38. Am I correct? Therefore the greatest number we have to write in the numerator. That is the greatest number here is MSE, that we have to write in the numerator, and MSE is a smaller number that we have to write in the denominator. The numerator, greatest number we have to write. Among these two, the greatest number is 828.78, and the smallest number is 403.38. So MSE we have to write in the numerator, and MSE we are writing in denominator. So if you divide 828.78 by 403, your answer would be 2.06. I repeat again, this is the greatest number we have to write in the numerator. This is the smallest number we have to write in the denominator. So if you divide 828.78 by 403.38, the answer is 2.06. So 2.06 is the calculated value of f column wise. So FC equals 2.06. The similar way we have to calculate the F value for row. F value for row. For that, these two you have to compare. MSR 8744.98. 8744.98. MSE 828.78. 828.78 MSE. So which is the greatest between these two, MSR or MSE? Yes, particularly, definitely MSR greater, because it is comes in thousand. This is comes in hundreds. So 8744 is the greater, that in the numerator you have to write, and 828.78 is a smaller number that you write in the denominator. As I already told you, we have to compare the big number you write at the denominator place, and small number you write at the great number you have to write at the numerator place, and the denominator you have to write the smallest number. So MSR is the greatest number here, and MSE is the smallest number here. And divide this by this, that is 8744.98 divide by 828.78, you will get 10.55. So the calculated value of F row wise, calculated value of F row wise equals 10.55. 10.55. So the calculated value of F column wise we have found out, and calculated value of f row wise also we have found out here. Okay, the calculated value column wise equals 2.06 and calculated value of f row wise is 10.55. Okay, now our job is to find out the table value for column wise. Table value of f column wise we have to find out. Table value of f for row wise we have to find out. How to find that? Now look at this particular expression here. Before that, come here. The calculated value of f column wise, the numerator is MSE and the denominator is MSC. The numerator is MSE and the denominator is MSC. MSE is different from MSC. So here MSE means square error. What is MSC? Means square column wise. Now the means square error wise. Okay, mean square error wise in the numerator and mean square column wise in the denominator. Now look at the numerator MSC. So come here, MSC. What is difference of freedom? 12. Okay, what is difference of freedom? 12. Which one? MSC. So that we have to write inside the bracket the first place. In the first place, which is the numerator, that's degrees of freedom we have to write. I repeat again, in the first place the numerator degrees of freedom we have to write. In the second place the denominator degrees of freedom we have to write. Okay, now MSC the numerator, you come here. What is degrees of freedom? 12. So that 12 we have to write in the first place of this particular bracket of f table value. Okay, now what about the second place? The second place is the denominator degrees of freedom. The denominators means square column wise, it's degrees of freedom, MSC. Now look at that, MSC 403.38. What is degrees of freedom? 4. So that you have to write on the second place. I repeat again, the denominator is MSC, its degrees of freedom is 4. I repeat again that in the numerator, what is the measure? The mean square error. The mean square error. That degrees of freedom we have to write first. In the second place, the denominator, its degrees of freedom we have to write. And here MSC is in the denominator. So MSC, its degrees of freedom is 4. So that 4 you have to write here. Okay. Yeah, that's way how to. Now for this there is a table. Now before that, now in this particular table, go back and see the table in which level we have to test this hypothesis. I mean, at which level we have to test whether there is a homogeneity among column wise as well as the homogeneity among row wise. In which level we have to test? It is not given here. So usually we take that 5% level. That also very important. Without level we cannot take the decision on the hypothesis. So we assume ourselves 5% level. Okay, so in the 5% level there would be a table, statistical table. So in that particular statistical table, you have to take 12 the numerator direction, the horizontal direction, 4 in the vertical direction we have to take. In the vertical direction you take 4 and the horizontal direction you take 12. The intersection of 12 and 4 will give you the table value for this particular situation where degrees of freedom in the numerator is 12 and degrees of freedom in the denominator is 4. So you go to the table and see it would be 5.91. So this value comes from the statistical table. Keep in your mind, from the statistical table we have to get this value. Okay, 5.91. So now what I understand is that the calculated value of f column wise is 2.06, whereas the table value of column wise at 5% level is 5.91. Okay, so these two values we have got. Now come to the row wise again. Here row wise, the same way you have to fill up this bracket. Okay, so what is the numerator? MSR. MSR is the greatest value. That was what we have written in the numerator. MSE is a smaller value. That is why we have written in the denominator. So MSR, its degrees of freedom is 3. MSR is the degrees of freedom is 3. So that we have to write in the first place as we did here. The numerator mean square row wise, that degrees of freedom is 3, that you have to write in the first place. The denominator MSE mean square error, its degrees of freedom is 12, that 12 you have to write in the second place inside the bracket. I repeat again, if you wish, the numerator measure MSR, its degrees of freedom is 3, that you have to write in the first place inside the bracket to find the table value of f. Then what would be the second place? The denominator measure. The denominator measure here is MSE. What's its degrees of freedom? 12. That 12 you have to write in the second place. Okay, the second place. So again, how we found out the table value of f column wise 12,4. The same way we have to find out table value for f row wise also. Okay, at the 5% level of significance. So again you have to go to the table, statistical table, Fisher's statistical table. There 5% level, you take the table there. In that table there would be a horizontal line and vertical line. Horizontal line denotes the degrees of freedom in the first place, and the vertical denotes the degrees of freedom in the second place elements. So first you take 3 on the horizontal line. Horizontal line you take 3, and the vertical place 12 you take. So this 3 and 12, it will be interesting intersection. That intersection 3, 12, 3 in the horizontal line, 12 in the vertical line, will give you the value 3.49. 3.49. So by this time what we have got is that the table value for row wise, table value of f for row wise, we have got as 3.49. So these two are necessary because it is two-way analysis, two-way ANOVA we say. Okay, so for two-way ANOVA we have to say whether there is no significant difference between columns. In our case it is treatments, as well as we should check whether there is a significant difference between row wise, or whether there is no significant difference between row wise, that is homogeneity exists or not. Here row wise is what? The food stuff, that's what given to us, semi-correct. So this table calculation is over by this time. Now next comes about the comparison and the conclusion. Comparison and the conclusion, that's what we have to get now. Okay, Now let us conclude about whether we have to accept the null hypothesis or we have to reject the null hypothesis. Okay, for this we have to compare these two, the calculated value of f as well as the table value of f. These two we have to calculate. Okay, and we have to compare that also. Similarly, to find the significance difference between the rows, we have to take these two, that is calculated value of row and table value of f for row. These two are very necessary. Now look at that. The calculated value of f is less than calculated value the table value of f. I repeat again, calculated value of f column wise, that is 2.06, and which is less than the table value column wise of f, that is 5.91. So this value is less than this value. So what we understand, we are accepting the null hypothesis for column wise. For column wise we can accept the null hypothesis, but what is null hypothesis column wise? There is no significance difference between feed stuffs. There is no significant difference, and that's what our conclusion. So after calculating all these things, just come here and compare if the calculated value of f column wise and the table value of f column wise. If you compare them, if fc is less than ft, then we have to accept the null hypothesis. Okay, so that's what we have here. In the case 1, what is the case? That is treatment case. Okay, so in the treatment case what we see here is that calculated value of f column wise is less than table value of f column wise. Now look at that, the calculated value of f column wise is 2.06, whereas table value of column is 5.91. so that's what we have here. So tabulated value is less than, calculated value of column wise is less than table value of column wise of f statistics. That is, you look at here, 2.06 is less than 5.91. Therefore calculated value of f column wise is less than table value of f column wise. So if this is the case, we have to accept H0 for treatments, because the column wise we are taking treatment here. Look at that, the problem. Treatment 1, treatment 2, treatment 3, treatment 4, treatment 5. So all these are treatments we are taking. So treatment wise, the null hypothesis accepted, and that's what the conclusion here. So what is the conclusion? There is no significant difference between the treatments. That means there exists a homogeneity between the treatments. How many treatments are here? 5 treatments are here. So there exists a homogeneity. All the fertilizers or treatments, all the treatments are acting here almost equally. They are similarly performing. That is the meaning of homogeneity, or that is a meaning of no significant difference between the treatments. So no significant difference means there exists a homogeneity between the treatments. How many treatments are there? T1, T2, T3, T4, T5. So 5 treatments are there. They all work together equally, almost equally, almost similarly they act. The performance of all treatments are almost equal. Homogeneity exists. There is no significant difference between the treatments. That's what we understand here. Now let us come to take decision on row wise. So row wise means what here? It is a food stuff. How many food stuff here? A, B, C, D. So we have to take the decision on the food stuff also, whether the four food stuffs act similarly, or there is a homogeneity, or there is a union such that they work together, and that's what we are testing here. Okay, so if you take these two values from the table, the calculated value of row wise equals 10.55. This is what the calculated value. So the calculated value row wise, calculated value of F row wise is 10.55. That is what the calculated value of F row wise. Now what about the table value of F row wise? The table value of F row wise is 3.49. 3.49. So what you understand here, this is greater than this. 10.55 is greater than 3.49. It means the calculated value of F is greater than the table value of F. Calculated value of F is greater than table value of F. Okay, so what we understand, when the calculated value of F row wise is greater than table value of F row wise, then the ANOVA theory or ANOVA analysis says that we have to reject the null hypothesis. Okay, that's what two-way ANOVA gives us the result, that if calculated value of row, calculated value of F for row wise is greater than table value of F row wise, then we have to reject the null hypothesis. For what? For row wise here. Okay, H0 is for row wise, that is for food stuff we have to reject the null hypothesis because the calculated value is greater than table value. Calculated value is 10.55. Look at that. This is calculated value 10.55. Tabulated value is 3.49. So if you compare them, this calculated value is greater than the tabular value of F. What the theory says, what the analysis says, if that is the case, we have to reject the null hypothesis. What's null hypothesis? There exists a homogeneity among the variables. And here, what are the variables? Foodstuffs. So we have to reject the idea that the homogeneity is not existing, or otherwise heterogeneity exists among all these foodstuffs. All these foodstuffs are not acting similarly. They are not cooperating one or the other. So if A is acting in a good way, B is not acting in good way. If B is acting in a good way, D is not acting in a good way. So there is no homogeneity. There exists a considerable difference. I mean, there is a significant difference among the foodstuffs. So, in the case of, as far as foodstuff is concerned, we have to reject the null hypothesis. If that is the case, alternative hypothesis only the chance. Therefore, the alternative hypothesis for foodstuff is there is a significant difference between foodstuffs or feed stuff, we can say. Okay, so alternative hypothesis is there is significant difference between feed stuffs. So our final conclusion is that since the calculated value of F is greater than the table value of F for rows, here rows gives you that the foodstuffs H naught is rejected because homogeneity is not there. Homogeneity is not there among foodstuffs. They are not acting equally likely. So there exists a significant difference between foodstuffs A, B, C, D. Therefore, the final answer is there are significant differences between foodstuff or feedstuff. Anyway, we can say foodstuff or feedstuff. So our final answer is that as far as the column wise is concerned, there is no significant difference between the treatments. That means as far as these treatments are concerned, 5 treatments are the T1, T2, T3, T4, T5. They are acting togetherly. That is, homogeneity exists between these treatments, whereas there is no homogeneity behavior exists between these foodstuffs. That's what our understanding here. Okay, so thus we have taken decision on this RBD, randomized block domain, or domain we can say, or randomized block design problem. Okay, so quickly the feedback I do want to give to you. This is a problem given to us, and it is asked whether there is a homogeneity among the treatments as well as among the foodstuffs, and the network is given here. The outcome may be the network here. The yield may be given network. Our aim is to say whether there exists a homogeneity column wise, that is treatment wise, and whether there is a homogeneity among row wise, that is foodstuffs, A, B, C, D, 4 types of foodstuffs. Okay, right, then we assumed null hypothesis. We know hypothesis means a blind statement for which the result can be obtained at the end of the statistical test. So we blindly say that there is no significant difference between feedstuffs as well as treatments, and that is blind idea. We call it as null hypothesis. And definitely the alternative hypothesis is yes, there is significant difference between feedstuffs, that is row wise, as well as treatments column wise, because if null hypothesis is not satisfied, we must have the alternative hypothesis. And then we calculated the calculated value of F for column wise, that is treatments, as well as row wise for feedstuffs. And the table value also we found out for column wise and as well as row wise. Here column wise is treatments, row wise is feedstuffs, and we subtracted 50 from all these matrix because to reduce the number so that the calculations would be very easy for us, and that's what we have done. And then all components we have calculated, and thereby TSS, total sum of squares, we calculated. SSC, sum of the square column wise, we calculated. SSR, sum of the square row wise, we calculated. And SSE, sum of square error, we calculated. Why we calculated? From that only we can calculate the calculated value of F row wise, column wise, and then we need tabulated value for column wise and row wise. For that we need F table here. Since the level of significance is not given here, we can take it as a 5% level of significance. And if you know this and all other things, we can calculate. So SSE we need, SSR we need, SSE need, and everything is very easy to calculate. From that we find out the calculated value for column wise and table value for column wise, calculated value for row wise, and tabulated for row wise. Comparing these two, we can accept the hypothesis or rejected the hypothesis. Particularly here about null hypothesis. Okay, so we compared these two. The calculated value of f column wise, we got 2.06. Table value of column wise, we got 5.91, and here calculated value of f is less than the table value of f. Therefore we accept null hypothesis for column wise, but here the column, here the calculated of row wise is 10.55, whereas table value for row wise is 3.49. so this value is greater than this value, so we have to reject the null hypothesis for row wise. So finally what we have got is that there is no significant difference between the treatments, but there is a significant difference between foodstuffs. Okay, otherwise we can say that there is a homogeneity exists between the treatments, that is 5 treatments are here, and there is no homogeneous behavior between the foodstuffs. Okay, so with that we come to the end of this particular problem. So dear students, I have taken the class nearly 1 hour, and I advise that you have to play this problem again and again, so that you will get the wonderful idea about solving the problem of two-way analysis. So here, solving the problem two-way analysis means whether you are accepting the null hypothesis or rejecting the null hypothesis for column wise as well as row wise. So this is what a good example for two-way analysis, and if God wishes, I will come with another problem with three-way analysis, where we are going to check whether the column wise, row wise as well as treatment wise there exists homogeneity or not. Whether column wise the elements are working similarly, or there is a homogeneity exists. Row wise is that homogeneity exists, all of them acting closely equally, and the treatment also, whether all treatments are acting closely equally likely. That problem comes in Latin square method, and if God wishes you come to this class, we will be discussing that. Till then, God bless you.